Dr. Marcello, it's all you now.
Wow, thank you so much, Mr. Sturman, for that introduction. That was so kind, and I'm really glad to be part of the entire process at the Tech Fest. But I have to say, I really enjoyed Tyler's presentation on design thinking. Wow, how appropriate for the hackathon, and how appropriate for how we look at open data. So what we're going to be looking at today is, I'm going to make the assumption that you don't know what open data is, or maybe you've heard about it, but you're really not sure what open data is and what you can do with it. And so what I want to do is just introduce the topic of open data, and then I'm going to show you two different ways of using open data as a sneak peek into possibilities for the hackathon. All right. Now, one thing I must say is at 4 o'clock when we start the pre-hackathon festivities, there's going to be a secret reveal of what the challenge is for the hackathon. So you are in the right place, being in the open data presentation right now. So I'm going to go ahead and share my screen in a second here. And as we go along, I just want to encourage everyone to think about possibilities. I think that's something that the entire hackathon has emphasized in a really big way. But when we think about possibilities for making positive social changes, open data is really something that lends itself to that process. Okay, so that's why I've titled my talk Opportunities with Open Data. All right, so what is open data? You've probably heard about it, and you're probably wondering what it is. And you might have heard people in like the public space talk about it. According to the opendatahandbook.org website, believe it or not, there is organizations that speak about open data, and that's all they focus on. But the definition is open data is data that can be freely used, reused, and redistributed by anyone, subject only at most to the requirement to attribute and share alike licensure. All right. So you've probably heard of Creative Commons and things of that nature. Open data is designed to edify the public, right? So if you're going to solve a problem in the public domain or the social domain, and you're really passionate about it, the open data gets you started in the right direction, because it gives you access to information about public themes, if you will. Okay, so the types of data that you might be seeking, we all know that, web pages are made of HTML, and you could print those pages out or save them and scrape data from those pages, right? But traditionally, you're going to see data categorized as data sets, either in CSV format, Excel format, JSON, XML, or text. And those lend themselves to being analyzed in a variety of different softwares. And you can imagine an Excel spreadsheet could have lists of a lot of different things, right? When it comes to open data, though, there's also a plethora, I love that word, of map data. And map data gets a little more mysterious. So today's workshop, both of the demonstrations that I do, are going to demystify the map data in a way that I hope that you can gravitate towards perhaps applying that in your hackathon problem-solving solution. All right, so let's talk a little about map data. Map data is nothing more than data that is based on the stuff that is in a map, right? So a map has a shape to it. That's a shape file. Shape files are basically, if you looked at a map of the United States, it has shapes, right? It has an outer shape, and each individual state has its own shape. So if you just focus on one state's shape, say that 3 times fast, it would have a particular state shape. So if you look at Texas, or if you look at New York, you kind of recognize that outline. So those are what shape files do. The map points that you plot on top of that shape file, right, are going to be basically pinpoints that are areas of interest, right? So it could be different restaurants, it could be different things that you want to point out on the map. So the shape files, just think of it this way, are the shapes that make up the map. It could be the entire state broken down by different counties. Each of those things have different tiles or shape files associated with them. And then the points are what you plot on top of there, right? Each county or each smaller subset of that shapefile will be a polygon. It will be a way of the software to determine that, hey, this is the state of New York, but guess what? This is Hudson County or Hudson Valley. And within Hudson Valley, this is maybe Orange County or Dutchess County or what have you. All right. So that's the overarching definition of map data. And then we of course have APIs or application programming interfaces, where you can basically use a URL or a web link to get at data and bring it into an application that you're planning on using that data with. Okay, so this is a very high level way of looking at the different types of data that are part of open data. So the uses for open data, I'm going to go through each one of these really fast because of course I have the cool demos to do. We talked earlier in the Tech Fest. I heard some of the presenters talk about democratic control or democratizing data. And that's really what open data is about. It's about being transparent to the public, about making sure everyone has equal access to data that is important and relevant to the public sphere. So that's what democratic control of data is really about. Participation. When you have access to something, you're then able to participate. So that's one of the uses of open data. Self-empowerment. If you don't know information and, knowledge is power, that kind of ideology, well, you're able to empower yourself by learning more about the environment around you. So maybe it has to do with resources that you need access to, or your family members need access to, or maybe it's about school, or maybe it's about jobs, right? You're empowering yourself to learn about what is available, what opportunities are available for me. That's another thing that open data can do for you. Here's a good one: improved or new private products and services, right? So tying back to Tyler's talk about design thinking, if you see a product out there and you say, that product is okay, but I can envision making that product even better. And maybe you're not part of a, research and development team. Maybe you're just the average layperson, but you have some really cool ideas. This is where you're able to take that open data and, analyze it, and then start thinking about, how would I redesign this product, which, let's say, individuals struggle with, or maybe find, is substandard, or service, right? Innovation. Really, when you talk about design thinking and taking open data and marrying it to that process of design thinking, you're innovating. You're taking your ideas and you're thinking outside the box, and you're putting a human spin on it. So you're taking the human element and you're looking at the user as a human who is a function of how they feel, how they see, all those five senses, right? And you're putting yourselves in the place of that individual, and you're innovating to find a solution to a problem that exists. Improved efficiency of government services. Now, we all have, I'm sure, run across a government service that we said, it would work a little bit better if we could do this, this, and this, right? And it could be waited too long on the line for something, or maybe, the days of the week when it was available, those things were problems. So you might address efficiency problems and effectiveness issues in the government services sphere. Well, that's where open data, a lot of the open data that's available is tied to the government, and the government is putting those valuable resources out there. And I'm going to show you some examples in a few minutes. So you might think of ways to make things better. Policies is also part of that. So how we measure, performance of, let's say, government, business, and other services, we could actually have an impact on how those policies are quantified and how they are qualitatively addressed. Again, any person, the idea is that any layperson can be part of this process. So that's what's really essential about this. And then the last one is new knowledge from combined data sources and patterns in large data volumes. And that's where myself as a data scientist, this has meaning to me, because I'm able to take that data and I'm able to analyze that data and determine what that data tells me, the story behind the data, what patterns do I see. But it doesn't take just a data scientist. An average person can look at a data set and say, wow, I see some really cool patterns in here. What does it mean? Can we investigate further? And so that's why I want to make sure everyone understands that any individual can look at a data set and find these patterns. You don't have to have, training in this. This is something where the human being is able to see those patterns. So it's really cool. All right, considerations with data and open data. So I'm going to throw some terminology around which you may see, you may hear about, and I want to demystify it. So data cleaning, pre-processing, and feature engineering is often needed when you use open data. The demonstrations I do today, I'm actually going to show you those processes, okay? When you get data and you download it, I'm going to guarantee you that it's very rarely clean. There's going to be blank data in there. There's going to be empty columns. There's going to be weird characters like Unicode, like gobbledygook, if you will. Okay, data that is probably not useful unless you do something with it, right? So that's really what data cleaning is about, looking at the data set and saying, okay, what can we do with this data? Can I even, as a human, read it? Or do I need to hire a special robot to parse the data and do something with it? So that's what, the issues with data is that they come from a vast array of sources, right? So different servers, different systems. And as they go through those different processes, sometimes the data gets corrupted. Sometimes it gets implicated, for I don't know, a particular server decides, oh, the data looks like this. I'm going to convert it because I think it's what, yeah. Servers are like little evil devils in the middle of the process. So what you thought the data was, it's not what it is. And so those data anomalies or issues, maybe it's not complete. It has quality issues. Maybe there are quantities in there that are just not valid. They don't make sense, right? All of that should be verified. So you don't want to trust all your data as being good enough to use until you look at it and make that assessment. So open data is about closing the data divide, and the TechFest really focuses on digital inclusion. Well, data division is also an issue. So when we don't give everyone access to data that can help solve their own problems or problems in the community, that's an issue. And that's really what the mission of open data is all about, to give access to every individual and to innovate and create solutions to problems. So literally, you could go to a library as a club, there's book clubs, there's gaming clubs, what have you. You could meet on a weekly basis and say, we're going to solve some problems. We're going to look at our community data and we're going to see what we can do to solve the problems that we see in our community. And you could do this as a collective. Of course, you'd have to be drinking coffee or some kind of beverage as you're doing this, because that's what we do, right? So many open data sources are public domain. They have no copyright protection. They are just out for the taking, if you will. So the reason that is the case is, the idea is transparency. You're putting the data out there as an entity, whether it's your local court system or whether it's your local government or what have you, and you're giving the data to whoever wants it. But the person that's, reviewing the data has to take a risk-based approach to the data. So you want to always verify, that it is valid and that it makes sense, okay? So the way that you do that, this is really simple. Who is providing the data? You ask that question. We're going to evaluate our data set by looking at who's the data, provided by. Is it Joe Schmo or is it, the state of New York? Good question, right? When was it published? How current is it? Is it relevant to the problem of today? Or is this data set perhaps talking about something that happened 5 years ago and we know for a fact, based on observation, that things have changed? So when was it published and where? Okay, and what's in it and how is it shared? How many hops did it go through to get to where it is that I'm looking at right now? If the data has gone through a lot of providers and a chain of providers, it may not be accurate. And so you always want to ask yourself, is this known good? Is this data usable based on what we know about known good? All right, so I have some links and resources. This, by the way, is available as a PDF on the Open Data Workshop webpage of the TechFest, excuse me. And the World Data Bank, or the World Bank, I should say, has some really good resources. There's an open data toolkit that you can avail yourselves to. This happens both at a state level, at a nation level, at a world level. So there's global entities all over the world that believe in open data as a movement. There's the handbook from the Open Data Handbook. So if you were wanting to implement an open data policy or procedure in, let's say, your organization, your community, you could look at this handbook as as a guide. And, what are we getting ourselves into when it comes to this open data? And then 50 best open data sources. That I love. Again, I'm not going to click on it now because we don't have time to go through all of those. Open data from New York State. I will be showing you that in a second, and also open data in New York City. Okay. So that's it for that part of the presentation. I'm going to now jump over to one of those data websites that I just talked about. So this is New York State. And New York State is one. There's also City of New York, but this is in the link I provided in the website area for the workshop. Okay. Notice they have a variety of different categories of data. And of course, COVID is the first, right? Because everybody's drilling into COVID data. But you can see they're broken down by different categories here. And these are all areas that the public is concerned about, right? Whether it's COVID, education. So I'm going to pick, let's pick one. Oh, I don't know. Let's go into public safety, right? As a category here. So when you go into the public safety area, these are all data sets. Now, you'll notice that they're categorized differently. This says data set right here, okay? So that means that's a data set I could download, and I'll show you what that looks like in a second. This is an external link. So what this is a link to another source in the state that provides this statewide imagery, okay? So you wanna pay attention to the categories that you see here. Here's another one. Here's one that's a map. So this gives you a map of New York State. So if I were to click on this, you would actually see a map pop up. We're going to be building some of these in a second, that utilizes data that is open data. So this is actually all the different fire departments that are in New York State. And you can kind of see how they're aggregated here. You can see that there's hotspots here. So you can click and zoom in and see all the different locations, right? The cool thing about this is you can actually download this data. I'm going to jump back to the prior page here. So if I wanted to see just the data sets, I could come over here and click on data sets, and I can jump right in, and I can actually get all data sets that I'm interested in. So let's quickly look at what a data set might look like. So for example, let's say I wanted to look at we'll do hate crimes. Why not? Hate crimes by county and bias type. All right. All of these are not necessarily a pleasant topic, mind you. But if you want to help a social concern, there's nothing better than looking at the data that's going to help you. So every data set is going to have a description about what it is. This starts in 2010 and it keeps on to today. You can see when the data set was last updated, very important. This shows that there's currency. It was provided by the New York Division of Criminal Justice Services. So you have to assume it's coming from a quality entity, that it's accurate. This is what we call metadata. Metadata describes all the different fields that are in the data set. This tells you how many times it was downloaded and viewed, right? You could even contact the data set owner if you have questions about the data. They tell you any limitations, additional resources, and then how many rows and how many columns. And if you've ever worked with an Excel spreadsheet, you know what that means. This gives you all the different fields, right? And you can expand that. These are very important when you're analyzing your data. And then of course the raw data. All right. Now, some of these you can see have a lot of zeros in them. This is a good thing because this is representing crimes that happened, and we want to see less of those hate crimes, right? So if you see a lot of zeros, and let me just quickly emphasize this. When I think of the content, right, that I'm looking at in the context, this is hate crimes. If I see a lot of zeros, I'm happy. If I see a lot of non-zeros, I'm not as happy, right? So zeros are not a bad thing. Zeros mean it was not represented as a positive yes, right? It's a no. This did not happen. All right. So just really quick, if I wanted to export this data, let's say I go to this website, I want to work with this data, it's related to the problem of interest. I'm going to click on export. When I do, I can export this as a CSV file. And then I can use this in my Excel or Open Sheets, what have you, Google Sheets, and I could work with that data. You can also see that there's other formats here, XML, TSV, which is tab separated. So you could even download it as a CSV specifically for Excel. All right, so this is how you would then download it. If you wanted to use an API, for those of you that are familiar, it's outside of the scope, but this is that URL I was telling you about earlier. Okay, so the URL, and let me just close this so you can see it. The URL, it's a JSON file. So I could actually bring that data into, and I've done this in the bootcamp, bring it in as a JSON file. And it just brings, it makes a call to the server, pulls the data in, that very data that you just saw, okay? All right, another example really quick is the New York City Open Data, which is concentrated in the city itself, right? So if you're new to open data, you can go in here and investigate and see what's going on. There's a whole bunch of things that you can look at, data sets by category, data sets by agency, and you can see all the different links to all the different good stuff, okay? So again, this is just another one. Let me go quick to yet another one. Now this is at the federal level. You'll notice there's 321,982 data sets here, okay? And there is a plethora of different topics, and this is just a free form search that you can do. All right, so maybe you want, and they kind of suggest some things here. Maybe you're interested in finance, you're interested in, student loans. I'm not interested in student loans. Anyone that wants to acquire mine, I'm selling it for free. Credit card complaints, it goes on and on, but this is at the federal level, okay? And there's a lot of individuals that will utilize this for research and other things. Another one, if you're really sciencey, like I love science, hey, NASA, right? And NOAA has data, the weather folks. So they actually have data sets that you could actually access under their data catalog. All right. And notice that they are tied to open government, which is an open data initiative. Okay. So the point I'm trying to make is open data is available globally, right? You just have to know where to go to get it. And then once you find it, you have to be able to go through those questions. Is it valid? Is it, known good? Are we getting it from a source that we know and trust? It doesn't need some cleaning, which it may. Those are things to ask, but the data is there. It's just working with it on a regular basis. And I will tell you that there are individuals that are part of different coalitions all over the world that work with open data in their communities to solve community problems. And that's really the power of open data. Okay. All right, that being said, we're going to segue over to the first demonstration, and that happens to be in Jupyter Notebooks, okay? Now, Jupyter Notebooks is part of, well, it allows you to work with Python, and what I've done is I've built a Jupyter Notebook looking at not the liquor authority, mind you, but on the website, we talked about cideries and wineries and meaderies. Well, there's a data set on the New York website, the New York Open Data website, that shows all of the different organizations in New York that provide cider and wine and so on and so forth. This is governed by the liquor authority. I promise you I'm only drinking tea. The liquor authority, they provide a current list for all active licensees in New York State. They have to, by law, provide that. Well, that data is open and available to you. Now, for those of you that like to do wine tours, perhaps, and go to the different wineries during the fall, maybe do fall foliage and what have you, and maybe you're into tourism and you provide some great outings for people that you know or what have you, you might utilize this website and their data to get into that data so that you can plan some day trips, right? So this comes from the Open Data portal that I just showed you. And the goal of this initial project was to look at it for patterns and trends. Now, I will tell you, this is an exploratory look at the data. It is by no means comprehensive. So I'm going to walk you through some of the lingo that is part of Python, Jupyter Notebooks, and taking a data set like the wineries and breweries and cideries and meaderies and distilleries, my goodness, and basically ingest the data. Okay, so that's the purpose of this little project. So the first thing you have to do when you're working with Python is you have to import libraries that you will use for your data analysis. So For any of you who have worked with Python, you'll see Pandas, which is used for data, analytics in general, manipulating your data. NumPy is used for mathematical functions. DateTime is based on things related to date. And anytime you want to use graphs, you typically will rely on a library like matplotlib. And in this case, PyPlot, which is tied to, Python. Who knew? And Seaborn is another one. Now, Seaborn allows you to take your maps up to another level. So I tend to like using Seaborn. And when I talk about, I just said maps, I meant visualizations, charts and things, right? If you want to get into the map sphere, then you want to bring in additional libraries. So Folium is a great library that allows you to support map-related functions. Now, you might be saying to yourself, well, what is a map-related function? Well, I'm going to show you what the data looks like. And again, when you first see it, you might look at it and say, this is very scary. And I want to demystify the data so that you're not afraid, because it really is. If you took maps if you took geography in high school and as a youngster, when you used to like to look at maps, it's not mysterious. So Folium allows us to see those maps on the screen. And then this little guy right here, that stands for regex. I'm going to show you a little bit about regex. Again, you're not going to be an expert in regex, but I'm going to hopefully orient you to it. All right, so we need to read our data into a data frame. And that's what this line is doing here. We're basically taking our CSV file and we're reading it as a CSV file, using Pandas to do that, and assigning it to DF, which is a name. All right, so by clicking run on that cell, I just executed that. And you can see it gave it a number with no errors. And that's when you go, yay, right? For any of the students that took the boot camp, anytime you executed and you didn't get a number and you got a big error, that was boo, right? Well, this is a yay. So now I want to see the first 5 records of my data set, my data frame. Okay, I'm going to show that to you. This is what it looks like. So in this data set, we have a serial number, we have the county, we have license type code, license class code. Remember the metadata I just spoke about? Well, knowing what the metadata, what these things are, by reading the metadata, you'll say, oh, the class code, it's this thing, right? So the metadata is very important, kind of like a data dictionary. The certificate number, the premise name, the DBA. Notice here it's NaN, meaning it wasn't assigned. It's basically, non-existent, if you will. The address. Now, when we get into the address and maps, at minimum, Google Maps and things of that nature, any software that renders a map has to have this address, right? If they don't have this, they have to have something else, which I'm about to show you in a second. City, state, zip, license issued date, license expiration date, the type of operation, method of operation, I should say, whether it's a brewery, a distillery, winery, yada, yada. And all the way over here is the geo reference. Now, you'll notice what they did is they have this as a point system. There's a latitude and a longitude. The longitude is first, the latitude is second, okay? In a minute, I'm going to clean the data so that they're in separate fields, because as you can see here, they kind of wrap around. It doesn't make it very easy to read, okay? So while I could leave it alone and not do anything with it, I'm going to show you how to split it out, okay? So you might be asking yourself, well, how big is this data set? What's the shape of it? How many rows and how many columns? Well, by running this cell, it tells me I have 1,524 rows and I have 18 columns. Yay. Okay. Next thing I want to do is I want to identify what the summary statistics are. Sounds really mysterious. It's really not. I get my column, right? Each column has a name. We've already seen that. I see how many of them are not null. Now, I know that there's 1,524 records or observations. So if it says 1524 here, I know there's basically all of the records are filled in that column. But when you get down to DBA, remember we saw those NaNs? Well, guess what? We know there's a lot of holes in the data. See that there? This 872 means that I'm missing some data in that column. Same thing down here in premise address 2, I'm missing data. So let's talk about that. If I'm missing data in a particular column, you don't automatically delete that column, or what we call drop the column. It is logically correct that many will not have an address 2, right? They just have a street address and they don't have a second one like a PO box. So if you were to just wantonly delete records that could actually cause data loss, which means that you've lost a lot of the rich data that you may be relying on. Okay, so think about it this way. What's the purpose of my data analysis, right? And before I start deleting records because there's holes in them, I want to make sure that I'm not doing a disservice. And I'm going to show you how to quantify that in a second. I also get something that's super important, and that's the data type. Okay, so a data type basically tells me what I can do with the data. If it's an integer, it's a number, right? So integer, 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 and the rest are objects. Objects are basically categories of data. They're categorical data. So think of it this way. Counties have a name. They're nominal. That's an object data type. Okay. Now, if I need to treat it differently, I may have to convert it. And I'm going to show you how to do that. Hint, hint, wink, wink. When you're doing the hackathon, Google it. If you're not sure how to do something, Google it. All right. I can promise you that there are things out there to answer your questions. It's as simple as, no different than when you were younger and you went to the library saying, I wonder. Google is your new library. Okay. All right. Now, let's say I wanted to determine how many null values I have in each column, right? I can actually run this formula is NA, and I can actually quantify it this way. I don't know about you, but it's a lot easier to read than having all this in here. I like to quantify it so I can say, oh, this is logical. This I don't really care about because it's doing business as, it's a business nomenclature, not interested, doesn't matter. License issue date, the relevance to my data analysis right now, it's not related, so it's a non-issue. Same thing with days and hours of operation and other. These two things are not going to impact my data, my analysis. Now, since my analysis is driven on maps, if it's blank in the geo-reference, I've got a problem. Now, here's my problem. If there's no data in that column, I could actually use Google Maps and fill it in based on the street address. But given my time constraints of the workshop, I'm going to pretend I don't have the time. And we have to assume in the hackathon, you may be time constrained. So you might have to say, well, it's only 88 records. Does it matter? What would the loss be, right? You have to ask yourself these questions. So I'm going to show you how to do that, all right? So first thing, I'm going to make an executive decision, which you're going to have to do in your teams during the hackathon. I'm going to elect to drop those 88 records. So this is the code for dropping those records. So if it's NA, drop any NA or blank using the subset of georeference, basically identifying this column, any data that is null, right? On the axis 0, meaning at the observation level, right? Not access 1 at the column level. We're not deleting the entire georeference column. We're deleting all of the rows that have no data in georeference, right? And so we're going to run this command, and that's going to quickly delete those records. Woo, gone. Now, what if we deleted the rest of the records? What percentage of data loss would we have? As data scientists, we always ask ourselves that. Now, this is scary looking code, all right, I grant you. But the idea is to get the percentage of records that are blank or missing relative to the whole, okay? And when I run that, I get to see very quickly that there's a 95% loss rate on days in operation, right? So 95%, 85% for other, right? 79% for premise address, 42%. Now, we've already talked about that these columns don't matter when it comes to the data analysis that my goal, my purpose, what I'm doing now. So it's a non-issue, but I wanted to show you how to get a quantification of percentage. If it's a high percentage and you experience too much data loss, you might want to find a different data source, right? So let's say you find a data source, you think it's going to be great, only to find out that it's missing so many records in a column of interest, one that's very important to you, right? So let's say going back to the hate crimes example, let's say your focus is to solve the hate crime problem, but you notice in a particular region that there's no record of any hate crimes, and you know that hate crimes happened. You might want to find another data set. Because if you start eliminating all those records, what happens is now you haven't represented that area, that region. And if your goal is to solve the problem, you're eliminating certain areas from your focal point, right? So just think about it. It's just a matter of informing yourself. All right, now we get into feature engineering. Georeferences, right? The georeference that I pointed to earlier had a point system associated with it, and it was put together. We had the latitude and longitude in one column. So what I'm going to do now is copy that data to a new column I create. That column is going to be called georeference point. It's just a new column. Give me a new column and copy all the data from the georeference column to that column. So I have a clone. All right, that's what this first chunk of code is doing. The next chunk of code, and let me just show you something really quick because it might make sense if I do it this way. All right, let's just give the first 5 records again so you know what I'm doing here. Remember this here? So you can see I cloned it, right? Right. What we want to do is we want to split the latitude and longitude, and we want to put latitude and longitude in separate columns so that we could treat them that way when we bring in our map code. All right. So what I've done is I've cloned them. Now I'm going to get rid of the parenthesis on the end. That's what the -1 is. All right. So I'm going to strip off using -1, the parentheses on the end, and then I'm going to strip the first 7 characters. So that's the word point, the space, and the parentheses on the front. All right, so if you ever heard of trimming leading and trailing spaces, that's exactly what I'm doing. It's using the position and it's cleaning the data based on that. So I've done that, right? So now I've stripped off the parentheses and the word point and the space, but I still have the latitude and longitude in here. You see that? So what I'm going to do now, and this is feature engineering, is I'm going to show you some scary code, but you have the recording, so you'll be able to grab the scary code. I'm actually going to create 2 new columns called latitude and longitude, and I'm actually going to run a little for loop, and I'm going to take the data, split it apart, and put it in its respective columns. Okay. Again, what it's doing is it's taking everything, and I'm going to use a very non-technical way of doing this. You see the space here in between the longitude and the latitude? It's going to say take everything from the space to the left and put it in one column, the longitude column, and everything from the space on the right to the end and put it in the other column. So it's a delimiter. The space is a delimiter, a way of dividing. Okay. So that's what I'm doing. That's what this code is doing. So I'm going to run it, and it's done running, and I'm going to look, and voila, ski. There we go. All right. Now I've got my latitude and longitude split out. And now I can actually say that this is X and Y. I can actually talk to it any way I want. My map code is actually going to do that. All right. And I'm going really fast because I've got another one I've got to show you. So don't mind me. I'm going to now drop the column georeference. I don't need it anymore. And another issue I have with data cleaning is I've got a bunch of columns with spaces. So premise city has a space. I want to put an underscore so that I don't have any spaces in my column names. That I'm going to do by using regex and replacing the space with a dash or underscore, I should say. All right, and that's accomplished that there. You can see now I have underscores. I'm then going to assign the latitude and longitude to locations and a list of locations that the map code will be able to use. All right, you can see here it's actually an array of locations, the longitude and the latitude, comma separated so that the map software can look at it. And sure enough, this is how the map software is going to, or map code, I should say, is going to perceive it. This is giving the map code where to start on the map. Do I want to start in Europe? No. I want to start in New York. Where in New York? Well, this is meteries. This is the whole state of New York. So I'm going to assign to a variable M the location that I want to start. When I zoom in on the map, that's where I want to be. Okay. Now I'm going to take those values and assign it to the locations map. Very simple. Then I'm going to add a heat map. Now a heat map is a concentration. It's colored map that based on the shading, it tells you the concentration of wineries, cideries, and so on and so forth. So here we have it. All right. You can see Wellsville has quite a bit. And when you drag this around, you can kind of see. Now, if I zoom out, you can see Now everything pops on the map. Now I get some shading. Ooh, check this action out. So now I can see the concentration in my map of where these, I'm zooming out, by the way. Now you're starting to see the state of New York, right? Okay, so you can kind of see that New York has quite a few cideries, meteries, and all that fun stuff. And you can see that the shading tells us. So the bright red is a high concentration. Now you can kind of see New York City, right? High concentration of wineries and such. There's more of a concentration over here. Kind of cool, right? Again, for the sake of time, I'm whizzing through this. I want to show you the R version of this. I'm going to add a tile layer. And by adding a tile layer and zooming out a little bit more, you can kind of see, come on, whoop, just a little bit more data here. Not a lot, but some, okay? You can see the concentration of where those places are, all right? And then I'm going to add some layers. Now, the reason I'm doing this, you'll notice over here, there's a new little legend that you can interact with your map. This is one way of looking at it, but if I click on here, I can actually change the style of map. All right, so now I'm zooming out again. I look at the map a little bit differently, right? The terrain is a little bit different. Maybe I want it to be, that's kind of cool, right? That shows really how New York pops. Color-wise, you're able to see it a lot better. Here's one that's OpenStreetMap that gives you, a traditional map style. Here's another one that gives you just the terrain. So different aspects of maps based on what you're trying to convey. All right, and that's really, but this layer, this legend layer, by adding those, you allow the user to interact with the map at a better level. All right, really quickly, because I want to get to the R1. All right, so here are some key locations. We can keep only the columns we care about. I'm just going to quickly run these because time is of the essence. And I'm going to display a map with markers on it. So now, let me zoom out. And now I've got some cool markers. Check this out. So now, and I don't have a lot of time, but if I mouse over these markers, you can see the name of the brewery. I should probably zoom out because, there's a lot of them. So that's why it's chugging in the internet connection here, right? But let's say I want to see, oh, this one's this particular brewery, right? This one is a different one. I'm clicking on each one. Fort Drum has Nikki and Troy. Let's see, we've got another one over here, Paradox. So you can kind of, see where things are located, and you can choose what shows up on the pop-up. All right, pretty cool. All right, so that's in Python. I'm going to quickly show you an equivalent in R, but this is based on Dutchess County. Now, really cool, and I'm hoping that everyone can see my screen. All right, I haven't gotten any alerts, so I'm going to assume you can. This is R.
Yes.
Okay, thank you. This is R. So I'm going to quickly go through this. Keep in mind, hackathoners, you have this same R starter code in your toolkit, but I'm not going to show you the toolkit till we actually start the hackathon. There's other goodies in there, I promise you. All right, so I'm going to again load some libraries, okay, very quick. And you'll notice that when I load my libraries, it basically gives me some indication that all is good. This is going to be Dutchess County data that I got from the Dutchess County website. All right. I actually have a shape file from Dutchess County that was provided by the Dutchess County government that gives me the municipalities or the boundaries or polygons for Dutchess County. So I'm going to load that, and that just gives me a nice data frame, and you're going to see it. It takes a little bit to load because there's a lot of geographical in there. There's 31 observations and 7 variables. So by loading that shape file that I got from the government, I get all my latitude and longitude, all my geometry, the actual shape area, and the name that we care about, Red Hook, Milan, yada, yada. It's map stuff that looks scary, and that's why I'm trying to demystify that for you. All right. I also have 2 CSV files that I downloaded from the government website, one for fire EMS and the other for police. So you can see these are just CSV files that I've read in. Okay, I'm going to be using these, all 3 of these in my map. So I'm going to load my geospatial data for my EMS. You can see down here that everything happened the way I wanted it. It loaded the EMS data. And now I'm also going to load the geospatial data for Dutchess County. All right, police stations. I'm then going to apply a function that allows all of the words to be title case. When you have a pop-up that comes up, if you have lowercase, uppercase, it makes it hard to read. So this function just makes it all title case. I'm then going to decide what I want to be the pop-up when I mouse over. So it'd be nice to see the location of the municipalities. So, think of the different towns that I just referred to. That's actually going to give me my towns. I also would like to see the name and address of the fire companies and the address and department name of the police station. So these are all the things that will pop up when I mouse over on the map. And you notice that each of these data files are providing the information for it. This is actually just creating HTML, raw HTML, but pointing to those columns in the data set. All right. I'm then going to make a map using Leaflet. Now, Leaflet is a very cool software that just allows us to build a map, very much like you saw. I'm going to use the different locations to create a color palette. And that's what this is doing here. When I build the base map, you're going to see the base map, which is the boundary of Dutchess County, and the polygons for each city, which is the municipality. So think of a map, it's broken up into chunks, right? And I might want to focus on one particular city or what have you. So that's what this is doing. It's adding tiles for a group called Dutchess County, polygons for each of the municipalities, and then markers for the fire and the police. Okay, scary looking code, but you can repurpose this code. I've given it to you. So I'm going to generate that. And one final thing, I'm going to actually build layers for the legend and generate our map. Woohoo! There we have it. Now, I got all these files from Dutchess County, and Dutchess County, as you know, was a sponsor for the hackathon. So I figured I'd highlight them. This is an outline. You can see the outline. This is the base map. So if you see the dark black, right? Yes, the links are available now, Patrick. That's a great question. Those links are available on the Open Data website. The links to the toolkit, the hackathoners will have to get when we reveal it. And that will be actually right about 4:20. So we have source code, all right? Source code. Okay, now this is an outline of Dutchess County, and you'll notice that Dutchess County is all in black, okay? Each one of these, when I click on it, that's Rhinebeck. Here we have Milan. I'm clicking on each one, Stanford, Northeast, Armenia, right? And let me zoom in so you can see it better, Washington. These are all part of Dutchess County, right? Let me zoom out. Oh, I went too fast. Okay. This is actually where the New York State Police in Dover is, and this is their address. Now, I could put additional data on that pop-up, all right? I just chose 2 fields, right? Here's another one. Here we have the sheriff's in Beekman substation, right? Here we have New York State Police in the Thruway, right? Let's use a little yellow dot. Oh, the yellow dots, the little dots are the EMS providers. So there's Alamo Ambulance. Here's another one, location Clinton, and then we have West Clinton Fire Department. So if you'll notice on the upper right-hand corner here, I have a legend. I can actually turn off the EMS and just focus on the police, right? So here we have the different police departments, okay? And you can see where they're located. Now, keep in mind, maps are not limited. You could have so much information on them. What's kind of cool is if you wanted to provide a map to the public to find schools or after school programs, or find all the different libraries in your region, or find where all the summer camps are going to be, or perhaps find, anything that people are looking for. The beauty of using the libraries that we used is when you bring this up on a cell phone, it actually looks normal. So you can actually, it's responsive for a cell phone device or even an assistive device. So if someone is using a tablet or what have you, an iPad, they're able to see this map and interact with it very well, very easily. So that's the beauty of this technology. If they tried to load the proprietary softwares that are out there, and I'm not going to mention them, but if they tried to do that, they wouldn't be able to work with it per se. It may be very difficult. This is lightweight, easy to work with. And of course, if I wanted to turn off the police, I could do that and turn on just the fire stations, and I could determine what is happening where. Okay. Now, I'll give you a little story before we take questions. I actually worked for a little while for the Department of Health in Ulster County, and we focused on the opioid crisis, and we were able to determine where resources were needed in the county based on pinpointing where overdoses were happening in the county. And that's something that was very important to me. You might be thinking of something in your community that's very important to you, and you may want to provide information to individuals to help them. And so you want to be thinking about what is needed in the community and what can I do using open data to solve these problems. Keep in mind, all the software I use today is you don't pay for the software. All of the data I've used is free, it's open data, and you literally could address a problem in your community using these open data resources. So I hope this has been helpful. I am going to stop sharing my screen and take some questions.
Hey,
This
Cynthia.
was wonderful.
We had a question from someone. Patrick asked how can we recognize or properly handle bias of the data? Are there some questions we need to ask or other details we need to use to check our data?
Absolutely. So the first thing is, where's the data coming from? That's the big thing. If it's coming from an entity that you know and trust, that is a good start. Now, I will qualify that statement by saying that we all know that the individuals that create data can be prone to bias. And that's a problem we talk about in the data science community. Anyone could make changes to the data and we might not know about it. And so what you want to do is look at the patterns in the data and determine, are these patterns representative of other known good data sources? Are they credible? Can I look and corroborate that data with another known good data source and say, these are reasonable given the other data that I have at my disposal? But that is a very important conversation that we have in the data science community, and definitely something that we could talk about further, but that would be my start. Where is it coming from? And do I trust that source?
Right, awesome. Other questions? Let's see, it would be great to have a recording, and Yulia already indicated that we are going to make that available. And Patrick also asked, are these links available now and where will they be posted? I think that's a part of your
that's my reveal. Yes.
Reveal. Yes, that's what I was thinking.
Yes.
All right.
Yes.
And Connor asked, what programming language is being used to program in the tool?
Okay, so the first one I showed was Python. The second one was R. And if you're going to get into data science or data analytics, you definitely want to know both of those. All right, R and Python are really cool tools. We offer boot camps in that, but each one has its own we'll say quirks and or specialties. R is more statistical in nature, all right? So there is more of a scientific edge to R, but you can create maps in both. And that's why I showed both. Really, both tools can be used to work with open data.
All right, awesome. Anybody have any other questions? Let's see. Oh, Connor wanted to know, is R similar to C++?
To C sharp.
Yes.
Yes, that's okay. That's all right. Yes, R is similar to C sharp. It is, let's put it this way. It is more like C sharp than C++. And if you know all of the data structures and you know all of the control structures, right? How to select, how to do an if statement, right? How to do a loop. If you know those fundamentals, you can manipulate it in R with no problem. So syntax is very easy to pick up if that's what you're asking.
Awesome. And one more question. If there are multiple maps or shapes, how does the scaling normalize these to common mapping scale? For the example, GPS versus Dutchess County.
Excellent. So that's a great question. So what I showed you was actually using a WGS 64. And when we go into the reveal, I'm going to be talking a little bit about the World Geodetic Scale. All right. And I actually provide a hyperlink in there. So there are different scales, and you want to make sure that when you read the data in that you convert it accordingly. And in my quick go through in the code and in the Duchess starter code that you have in your toolkit, I'm winking, you'll see some comments where I describe what that is, and I provide a link to the Wikipedia that talks about scale. So if you're using Esri or you're using OpenGIS or what have you, you want to make sure that you're using a proper scale. So for example, I got the data from Ulster County or Dutchess County in one scale. I had to convert Dutchess County to the scale that my R code was referring to. All right. So, and I'm going to give you a recommendation that you stick with the scale I gave you in the starter code. Hint, hint, wink, wink.
Hint, hint.
Okay. Hint, hint, wink, wink.
All right. That's awesome. Any other questions before we kind of quiet down this session and get ready? A lot of hints and winks for sure.
Yes.
Absolutely. Absolutely. Cynthia, you are amazing. I can't wait